Finding spatiotemporal coordinates in four-dimensional space. Earlier we mentioned that the theory of relativity makes us realize time and space are one. Together, they form a collection of spacetime. This brings the concept of four-dimensional spacetime to the surface. Usually we can use three numbers or coordinates to represent a location in space. For example, we would say something in a room a little 7 meters away from the front wall, 3 meters from the wall at the back and 5 meters from the floor. Geographically, we often say that a point is at a certain latitude, longitude and altitude. Of course, if the range is extended to space, we can also follow the distance from the sun, the distance from the surface of the planet and the line from the moon to the sun, the angle between the sun and the line of nearby stars to describe a location. However, these coordinates are used to describe the sun, location in our galaxy, or the position of our galaxy in this group of galaxies. It didn't do much. Even so, we can still use a set of each other overlapping fragments of coordinates to describe our universe. In each fragment, we can use three different coordinates set to indicate the location of a point. In the theory of relativity, an event is in a specific time and space, a specific point. Something happens, so we can describe it in terms of four numbers or coordinates. Of course, the choice of coordinates is arbitrary. We don't have to deliberately always use the same coordinates. Instead, any three definitions can be utilized: good spatial coordinates and time measurements. In fact, in the theory of relativity, there is no real difference between time and space coordinates. People can choose a new set of coordinates. For example, to measure the position of a point on the ground, we can use how many miles in the northeast and how many miles in the northwest of the United States to measure how many miles north and how many miles west of the United States, i.e. the old time, in seconds. The above is a combination of time and space. The space created is the four-dimensional space, i.e. in the length of ordinary three-dimensional space. There is an additional timeline on the three axes of width and height. There's a lot going on in this four-dimensional space, and everything can be represented by a point in a four-dimensional space. For example, on May 21st, 2024, you go to the library to borrow a book. Then the event of borrowing books can be used. A point in four-dimensional space is represented. The time and place where the borrowing takes place corresponds to the time and space points. Four-dimensional space is unthinkable. It's easy to draw a two-dimensional spatial diagram. You can also build a three-dimensional space, but what a four-dimensional space looks like, no one has really seen it yet. However, we can use two-dimensional diagrams. Time is indicated by the direction of increasing upwards. The horizontal direction represents one of the spatial coordinates. And like this, regardless of the other two spatial coordinates or sometimes through a graph of coordinates that represents one of them by perspective. It is called a spacetime map. Of course, there is no such thing as absolute time and space. So there won't be a single four-dimensional space. Usually we call a four-dimensional spacetime. The graphs are all spacetime maps that vary from person to person, and it is determined according to the state of movement of that person. Therefore, everyone has their own spacetime coordinate system. And everything that happens to you can be represented by a point in the four-dimensional space.